Hi everyone, Liz Klimek here, Planetarium Manager at the South Carolina State Museum. Well, welcome to November and welcome almost to the weekend, which isn't too far off. So that means it's time once again to check out what the universe has in store for us over the next couple of weeks. So without delay, let us fast forward just a little bit to this upcoming Saturday, November 7th at 8 p.m. Now, since daylight savings time has ended, you don't have to wait too long in order for it to get totally dark. So, like I said, this is 8 p.m., already dark. We're looking directly south, as we typically do from right here in Columbia, South Carolina. And getting lower and lower in the west night by night, but at the same time getting a bit closer to each other in the sky every night are the gas giant planets Jupiter and Saturn. And then if we look high up in the opposite part of the sky, high in the southeast, we have the brilliantly shining reddish orangish planet Mars, shining brightly high up above. And not that far from Mars, we have these stars forming a big square in the sky. This has been nicknamed the Great Square of a constellation called Pegasus, which is half of a flying horse doing a very impressive backflip over the entire night sky. Now, rising behind Pegasus towards the east, let me pan our gaze over towards the east so you can see this better. There is an object over here that's rising. I'll get a little bit closer. It's still kind of low, so I'll advance time a little bit. This is 8 o'clock. On the night of the 7th, we'll go to 9 o'clock, so it's a bit higher. This is an object I like to point out in the sky because it frequently gets mistaken for the Little Dipper. And I totally understand why. It is little, for starters, but if I stare at that a good long while, I can definitely imagine a dipper shape there. I don't know. What do you see there? But it's not the Little Dipper. It's not a constellation or star pattern of any kind at all, but it's a star cluster called the Pleiades, or the Seven Sisters. So star clusters are collections of stars that are all traveling through space together as one unit or group or pack or family, if you will. I like to think of them as a family of stars because all of these stars form together out of the same giant cloud of gas and dust, and they're all held together by each other's gravity. Now, this is very different from something like a constellation, and if I zoom us out here so we can see Pegasus a bit better, stars in constellations are at very different distances from us and from each other. So they have nothing to do with each other in space. They're all doing their own thing. They're moving in their own way. And basically, when we look out into the cosmos, we just see these stars in certain positions, and our imaginations conjure up images like this square tipped on its side, for example, half of a flying horse, or maybe something completely different that you might see in this pattern of stars. But they have nothing to do with each other because they're not associated with each other in any way, unlike star clusters like the Pleiades down here. Now, there are different kinds of star clusters, and the Pleiades is an example of an open cluster. And that means it's basically hundreds to a few thousand fairly young stars, all loosely held together by mutual gravity. And I can show you an up-close picture of the Pleiades here. So when we look at the Pleiades, we're only seeing the brightest of those hundreds to thousands of fairly young stars. And in this picture here, it kind of looks like those stars are embedded in a lot of fluff. And so there's some gas and a lot of dust that these stars are embedded in. And basically, that diffuse, softly glowing blue light just comes from the fact that all of the dust grains near those stars are reflecting the blue light coming off of those young stars. So that gas and dust isn't glowing on its own, it's just reflecting the light of those stars. And so that's why this sometimes gets called a reflection nebula. But let's go back to looking at the Pleiades up here in the sky. Now, the neat thing about the Pleiades is you don't need any special equipment in order to spot it in the sky. You just need a clear view in this direction. Although if you do have something like a pair of binoculars or a small telescope, that'll definitely let you explore this collection of stars a little bit better. Now I'm going to just zoom us out here a little bit, kind of go almost to the view we had before, just this time looking more towards the southeast. And now what I wanted to do is fast forward time night by night and go forward about 10 days. So we're going to stay at 9 p.m., but we are, starting here on November 7th, we are going to fast forward to the 8th, then the 9th, then the 10th, 11th, 12th, 13th, 14th, 15th, and one more, 16th. So this is going to be the night of November 16th, 17th. And you might have noticed that as I stepped forward night by night, everything kind of shifted over towards the west bit by bit, and that's just a consequence of the Earth going around the sun, and we're just seeing what happens as we do that, and our view of the universe changes bit by bit, and all of those familiar star patterns just kind of shift over towards the west. But I wanted to go to this particular date because this is going to be the night that's the peak of the Leonid meteor shower, which is going on this month. Now, meteors happen when little bits of space dust burn up in Earth's atmosphere, and they create what can sometimes be brilliant streaks of light that resemble stars falling from the sky, hence the term shooting star or falling star. But they have nothing to do with stars at all. Now, during a meteor shower, you're more likely to see meteors just because the Earth is going to pass through the debris left behind by a comet, and so there's more of a chance of that space dust hitting Earth's atmosphere. In this case, it's going to be the debris left behind by Comet Tempel-Tuttle as it orbits around the Sun once every 33 years or so. Now, comets are really messy things. They shed a ton. So as they orbit around the Sun, they just leave a trail of gunk behind them, little bits of rock. So dust and rocky bits. And around mid-November, Earth passes through the mess left behind by Tempel-Tuttle, and that gives us the Leonid meteor shower. Don't expect anything spectacular. At best, you'll see 10, maybe 15 meteors per hour, assuming your viewing conditions are excellent. But that doesn't mean it's not fun to go out and see if you can see any of them. Now, this particular shower is called the Leonid meteor shower because those meteors are going to appear to come from a part of the sky where the constellation of Leo the Lion is. So in order to see where that is, we're going to have to advance our clock later into the evening. So this is 9 o'clock, we're going to 10 o'clock, 11, midnight, so now we're technically the night, or the morning, excuse me, of the 17th. There's 1 a.m., 2 a.m., I'll go a little bit further to 3 a.m. And off in the east is something that looks like a backwards question mark, and that is the head, mane, and heart of Leo the Lion. So the Leonid meteors will appear to come from this direction, although you can really see those meteors anywhere in the sky. The higher that Leo rises, so we'll go to 4, 5 a.m., the better chance you'll have of seeing the Leonids. Now, the disadvantage is Leo rises really late, alternatively really early in the morning, so you have to stay up late or get up really early. But the great thing about this particular night is there's no moon. And we don't want a moon because the moon's light will potentially drown out those meteors, making it less likely for you to be able to see them. So this will be a great night to go out and look for meteors if they're going to be on the faint side. Now, there is a misconception that you need a telescope or binoculars in order to see a meteor shower, and that's totally not true. You don't need special equipment. You don't want special equipment. Meteors, you can't predict exactly when or where in the sky you're going to see one, so you would have no idea where to point your telescope, for example. Plus, meteors are very fleeting things. They only last maybe a second or two. So if you pointed your telescope at one, it would be gone just in a flash. So there's no point in trying to point a telescope or binoculars at them. To appreciate a meteor shower, what you really need are clear, dark skies and a view of as much of the sky as possible, because they could literally appear anywhere. So you do need to bring quite a bit of patience. So find a nice comfortable spot to do some stargazing and then just wait and watch. Do keep in mind that we are well into fall, and so the weather is pretty chilly, and there is a big difference between just standing outside in the cold and moving around. So if you're just sitting or lounging and doing some stargazing, you're going to feel that cold a lot more so than you would if you were taking a brisk walk, for example. So keep that in mind. Definitely bring a lot of layers, maybe a nice warm beverage, some hot chocolate, or your favorite warm beverage to keep you cozy and comfortable. But whatever you choose to look at in this first half of November, I wish you clear skies, and hopefully this helps you enjoy what's up there. So thank you so much for joining me this time, and don't forget that the planetarium is open at the South Carolina State Museum. You can check out our show schedule at scmuseum.org to see what we are currently running. As always, take care of yourselves, definitely take care of each other, and I'll see you again next time.